Okay, this is industrial networking. And we're going to do going to be discussing project 2. Okay. So project 2 says we're going to program our SLC 503 to write a binary word which changes every 5 seconds to a node one more than yours. Then we're going to display it on the panel view. Okay, so that's the plan. So the first thing we do is establish communications. So we come up in RSLink, we go to the squiggly line in the middle, we are on the DH45 DF1 COM1 port, we say auto configure, and auto configure is successful. Now we are in communications with our SLC 503. We leave the RSLink program running in the background. If we turn it off, then we are no longer in communications with that program. We open the 500 English program, RSLink 500 program, and we go to comms. Let's see if I can do anything about that. No, I can't. Okay, so we're going to comms, who active online, and we click on our SLC 503 in node 1 because this is the DF1 connection, which is a serial connection. The only thing hooked up to the computer is this particular PLC at this time. We say OK, that's the one we want to be in communications with. We're in communications with it, and sure enough, it has my project 1 in it already. Alright, so we're going to go offline, and we're going to get rid of project 1. Okay, so we're going to get rid of project 1, delete, and we're going to save this as project 2 so that we don't forget and write over project 1. We look at our channel configuration. We see that channel 1 is node 12. I look up and I see I have node 12, so I'm happy about that. I look at my input-output configuration. I see that I have an empty spot in 6 and all the other cards are in the right place. I'm happy about that. Okay, so the project said to every 5 seconds. So every 5 seconds sort of implies I'm going to need a timer. Okay, so I'm going to go and add a run, add 2 runs. And if I have a timer, I'm going to have to reset the timer somehow. So we go and grab a timer on. My timer is my first timer, T4:0. That's the name of my timer. We're gonna call it 5-second timer, for lack of a better thing to call it. And what do we want it to do? Well, it can go in a time base of 1 second, and we want it to go to 5 seconds. And when it's done, we want it to reset. So we could have a separate line that says done reset, or we could do something different than that. So we're going to do something different than that, and we will have a normally closed bit that says T4:0/done. So now on the run, we'll go and hit the check mark here, and the only problems we have is in the short in run 1. So now, as long as this guy is not done, my timer's timing. As soon as he gets done, then he's open, and now the timer resets, and on the next scan he starts over again. So that saves us needing a run that resets our timer. And then we want it to write something, so I'm going to use T4:0 done again, and when it gets done I'm going to use a write instruction to write something someplace else. What am I writing? So it says write a binary word which changes every 5 seconds. Okay, so we need a binary word changing every 5 seconds. Well, that's fine. We'll go in when the timer gets done, we'll throw in a counter. So we'll do a counter C5:0, and we'll call it a binary word maker. Okay, so that's what it is, a binary word maker. And we're going to set the preset to 1000. And so we're going to go up to 1000. When we get to 1000, then we'll have to do a reset of him, so that's fine. Now, from experience, we know, or from reading the reading material, we know that a write instruction is not going to be able to write the accumulator of this counter. So what we're going to do is we're going to be smart enough, and we're going to go, and before we do anything else, we're going to go and do a move. And so I'm going to move the accumulator of my counter, C5:0.ACC, and we're going to move it into some integer, N7:0, seeing that we haven't used N7:0 for anything, and we'll call that our binary word to be written. Alright, so that's our binary word to be written, and now now we have something to be written. The timer is done, and we need to have a message instruction. So we go looking for the message instructions, and either I'm blind or I can't see them. And program control, no, not there. Shift registers, no, not there. Move logical, no, not there. Compare input output. Okay, so I don't see my message instructions. So we'll go view and instruction plat, and let's see, MSG. M, there's an R, there's an M, there's an M, there's an M, there's an M. Is that MSG? Yeah, so that's the message instruction. Okay, we're supposed to write it, so we're going to write it. Are we sending it to a CPU, or are we sending it to any of those other guys? Well, we're going to send it to a 500 CPU locally. That's right, it's going to be right on the network that we're dealing with. Now, we need 14 integers that are used for nothing other than this message, starting where? Well, we can't start at N7:0 because we're already using N7:0. But we can start at N7:1. Okay, so we have a control block of 17 integers starting at N7:1 going to N7:14 that we can't use for any place else in the program, which is okay because we're not going to be using them there's no place else to use them right now. I'm going to go to screen setup. We're gonna check for errors. Boom. So we still have errors associated with our message, which we expect. We'll get rid of the instruction palette and we'll go to screen setup. Double click. And this controller, it's a write command. And what are we writing? Well, N7:0 is what we're writing. And what's the size? One word. What channel? Well, that's a good question. What channel? So we come back and look at channel configuration. We have channel 1, channel 0. Channel 0 is the DF1 guy. Channel 1 is the network guy. So clearly we want to go to channel 1. If we keep this channel 0, then the processor is writing to itself, and it really doesn't care too much about that. So it's not going to give you an error that it's writing to itself. It's just not going to do what it's supposed to do. Okay, so now we know we're in node 12, so we're going to node 13, and we want this to be displayed on node 13. So we have to find node 13, and I'm still looking for node 13. Okay, so I found node 13. I find that there is an output card O: at slot 3. So O, that's not an O. Yes, it is. O: 3.0. So that's the I'm writing to that in that device, and it's going to be node 13 that I'm going to. So I put a 13 there, and then I'm done. Don't mess with anything else. That's all I got to mess with. And now we're going to check for errors, and we check for errors. There are no errors. And now we're going to go and maybe we should put a label on that. It's not going to let me. Put a label on the control block. Description, edit description, message to node 13. So we know what we're doing. Alright, so now we're going to do a download. Okay. Now remember that last display you saw that went away pretty quickly said operating system 302. In the panel view, that's something you're going to have to remember. It's a 503 operating system 302, and it never is going to change because until we spend the several thousands of dollars for new cards, it's not going to change. So now we're waiting for the program to write. All right, we're going to come back to run mode. We want to go online. And so now we're in run. We see that every 5 seconds my counter is counting. I'm going up to a new number. And now I'm going to go to node 13 and see if I can see it going from 4 to 5. And in fact, I did see it going from 4 to 5 on node 13. So our program's working right. The only thing we need to do is handle the panel view so that we can see the binary word on the panel view. Okay, that ends Project 2's video.